part B. So when you have an or statement, it's really hard to combine into one single statement. Okay, so we solve them separately. Don't try to combine this into a single statement like this using greater thans. It won't make sense if you do that. So just keep them separate when it's an or statement. All right, so we got to solve the inequality 2x minus 1. The whole thing divided by 3 is greater than 4. How do I do that? What do I do first? So just focus your eyes on this one, everybody. Treat it like an equation, right? Do you guys like fractions? Some of you do, but most people, they're kind of awkward to work with. So what do? You could multiply both sides by 3 to clear the fraction, right? Balance principle says you got to do it to both sides. So what do you get on the left side? 2x minus 1 greater than 12. Okay, can you add 1 to both sides? What do you get if you add 1? So we get 2x is greater than 13, or x is greater than 13 over 2. And by the way, the rule of thumb is if you start out with fractions or whole numbers, end up with fractions. If you start out with decimals, end up with decimals. So don't write this as 6.5, write it as 13 halves. But the reason for that is if you never deal with fractions, you're never going to be comfortable with them. So I make you deal with fractions that way. Okay, so in the second one, what could I do? We have 3 minus 2x divided by, the whole thing divided by 3 is greater than or equal to 5. So kind of a similar first step maybe. So multiply both sides by 3. And what does that give me? Won't these divide out? One thing I should mention here is this division bar right here is a grouping symbol. Okay, so you don't have to worry about whether or not you have parentheses there, whether or not the 3 minus 2x is grouped. It is. And so the operation between the 3 here and this quantity here is multiplication. And when that operation is multiplication, it's okay to divide like that. So you're just left with that numerator, aren't you? 3 minus 2x is greater than or equal to what? 15. Okay. All right, finish that one up for me. So subtract 3. What does that give you? Okay, go ahead and finish it up for me. Don't shout it out yet. I want everybody to have a chance to write it down. See if you remember what to do here. Don't shout out the answer yet. So we're going to have x, and then I think everybody will get probably a minus 6. Okay, go ahead and tell me, what should the symbol be? So you divide both sides by a negative, it flips the direction of the inequality, right? So you divide both sides by a negative 2, this guy's going to flip direction, right? And we get x is less than or equal to negative 6. And what statement connects all of these inequalities all the way down? It's an or statement, right? Any questions there? Okay. Now, when you have an or statement connecting two inequalities like this, it's probably better to put the less than statement on the left. So a good habit to get into would be to switch these around. X is less than or equal to negative 6, or x is greater than or just greater than 13 over 2 means the same thing. There's no reason why you can't flip the two sets around. And that's really what these are. These are sets of numbers. X is less than or equal to negative 6 is a set of numbers, as is x is greater than 13 halves. So the reason I flip them around is, that left-hand inequality is one interval. And that right-hand inequality is another interval of solution. And the left-hand one is now to the left on the number line if you were to graph it. So you want to have the smaller set of numbers on the left, to make a long story short. Okay, so if you're confused, you could graph both of these, and since it's an OR statement, you could graph both of them on the same number line and then transfer to interval notation. But let's see if we can do it without graphing it on a number line. What does the interval x is less than or equal to -6 look like? So -infinity, definitely a parenthesis around that, all the way up to, so that's the smallest it tries to get to, right? Never quite gets there. And then you're looking at x is less than or equal to -6, so what's the biggest that ever gets? It gets all the way to -6, and then what kind of symbol around it? Because it's greater than or equal to, the or equal to part makes it a bracket. And then instead of using the or, we translate it to the symbol. What symbol? Union. So put that in right away. Big old U for union. And then what does x is greater than 13/2 look like as an interval? So what's the smallest it ever tries to get to? 13/2, right? And then how big does it get, or try to get to? Infinity. What kind of symbol around the 13/2? Strict greater than, so parenthesis, and then parenthesis around the infinity as always. So that's it. That's your answer, yeah.
So is the infinity always kind of going to go on the side that the symbol is pointing to?
Well, if there's an infinity in the statement, it's always going to be on the right. I can tell you that. And if there's a negative infinity in the statement, it's always going to be on the left. But will there always be an infinity in the statement? No. I mean, we saw an example just a minute ago where we got the interval from 3 to 5, right? But yeah, if you ever make a statement and the negative infinity is not the very left-handmost thing, it can't be right. If there's a negative infinity in there, it's got to be on the left if you write it down. I mean, I suppose you could switch the two intervals around and then it wouldn't be, but if you follow the rule where you always put the smaller set of numbers on the left, the negative infinity will always be the left-handmost thing you see.